So, our quiz tomorrow is only going to have a couple of problems on it, and one of those is going to be a calculator problem. So let me throw one up here. Go ahead and get your calculators out. I'm going to make sure everybody knows what's going on. So these problems are not written down anywhere. I'm just making them up right now. So you will just have to write them down with me. So let's do A plus 2B plus 3C minus D equals 4. Now, you notice that I am not in any way, shape, or form rigging this. So we're going to talk about what to do with our answer when we finally get it. Because chances are it's going to be terrible. Because I just totally made these numbers up. But that doesn't change the way we start. We start by putting in our matrix, right? And the matrix that we put in, maybe I should write it up here. The matrix that we put in is simply all of those numbers. Now, you notice in those bottom two rows or those bottom two equations, there are things missing. When there are things missing, we need to put in zeros. Does everybody remember that? So here we go. I'm going to put in my A's, B's, C's, D's, and equals numbers. I got to be very careful to get all the zeros in the right spot and to get all my negatives in the right spots. All right, so is everybody have that ready to go? We're going to put that into our calculator. I'm going to go down because I'm out of room. We're going to put that into our calculator, and it is going to spit out another matrix. Okay? So let's put it in. Does everybody remember how to do that? How to put it in? Second matrix edit, right? How big is this matrix that I'm putting in? Dimensions, I mean?
4 by 5.
Yep, it's a 4 by 5. So that's first thing I put in is 4 enter, 5 enter. And then I just start putting in my numbers. Carefully, because wrong numbers will lead to wrong answer. Anybody remember what to do after you get them all in?
RREF.
Well, first I have to second quit, right? I got to get out of the edit menu because the only thing I use edit for is to put the numbers in. Once they're in, I'm going to quit out of there. And then I go back into matrix, right, Jacob? And back over to math. And then all the way down to RREF. And I'll press enter. So now RREF is on my screen. And then I'll press second matrix again and pull in matrix A. And oh my goodness, did you get a bunch of yucky decimals? So did you get, for example, in this top one here, did you get negative 0.112 blah, 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 blah? That look about right? Okay. Now, I don't want you rounding those off. What we're going to do is simply go to our calculator and press the math button, the button that says math on it. And the first option is fraction. So press enter a couple times. And it will give you the matrix with the fractional form and not those ugly decimals. So negative 7/62s, 325/62s, negative 81/31s, and, oh shoot, I can't read that.
Negative 91/62.
There it is, negative 91/62. Thank you. And that then is the answer to the question. So if it comes out nice, neat numbers, then you don't have to worry about that. But don't be rounding off a bunch of crazy decimals. Just change it into fractions, and then you'll have your nice exact answer right there, A, B, C, D.
Mrs. Ford, what did you do to get the like the second matrix, or like with all the zeros and ones?
You go into second matrix, click over to math, down to RREF, and enter.
Okay.
Okay, so one question on tomorrow's quiz is going to look just like that. It's going to have this bunch of equations that I'm just going to make up. You're going to type them in, probably get something hideous as the answer, and then you'll be done. The second question is finding the area of a triangle given the vertices. So if the vertices of the triangle are, let's say, 1, -5, and 7, 3, and -4, 10. And we're going to find the area of this triangle.
Miss Ward, when it says A, B, and C, does it matter which order you write them in?
Nope.
Do you always have to put A in the bottom left?
Nope, you do not. You can put them anywhere you want. These are not plotted, and how you label the vertices of a triangle is irrelevant. However, what is relevant is, when we're going to find the area, you have to pick one of your vertices. And it doesn't matter which one you pick. You can pick C, you can pick B. I usually pick whatever one I've got in this corner because that's just the way my brain operates. But you can pick any vertex you want. From that vertex, there are 2 vectors coming out from it. So there's vector AC and there is vector AB if I use A. If I use C as my vertex, then I will have vector CA and CB. You pick a vertex, and then you have the 2 vectors coming out from it. Now, AC has a directed distance. I'm going from this point to this point. So how are my x's moving? I'm going from 1 to -4. -5. And then I'm going from -5 to +10. Yep. So that takes care of AC. Now I'm going to do the same thing with AB. I'm going from 1 to 7.
6.
Yep. And then from -5 to 3.
8.
Yep. Now, if you used a different vertex, like if you used B, and you did BC and BA, obviously you're not going to get these very same numbers. But your answer will be the same, I promise. But your work will look different because those vectors are different than these vectors. All right, once you've got your 2 vectors, just make a little determinant out of them. Just copy them down inside the vertical bars. and evaluate that determinant. Now remember, when you evaluate a determinant, you multiply down first, so it's -40. And then, what is that, 90? And then what do you do with those two numbers? My downs are -40. My ups are 90. What do I do with them?
You add them.
I subtract them. It's always downs minus ups. Somehow you got to remember that. That's going to show up in more than one test question. You've got to remember that determinants are downs minus ups. So anyhow, I get -30. So the area of the triangle is 65, because the area will always be the absolute value of the determinant divided by 2. So since I got a negative, I'm going to go ahead and make that a positive, and then divide by 2. Before you start freaking out about that, remember, I did these vectors in random order. If I had done AB first, and then AC, look what happens when I multiply. Won't I get exactly the same numbers, but this time it'll turn out positive? Yeah. When you're doing area, order doesn't matter, just take the absolute value and make it positive. All right, so that's what you're going to do tomorrow. So I would suggest that if you are at all confused or troubled, you go back to your notes where these things are covered and practice a little bit more.
Will we put units squared at the end of area, or just leave it at 65?
I'm not going to care one way or the other. Technically, yes, unit squared should be there, but I am not going to freak out or take off points if you forget that. I will just be super excited that you got the problem right. Not you personally, but just in general. All right, now we got to finish up our notes so that we can start doing a little bit of review. And I think if my records are correct, we only have one more problem in our notes to do. We have one more linear programming problem. The farmer in the field problem. So while I am setting my stuff up here, would you start filling in your chart? Remember, on your test, I will have the chart. I will have whatever it is, a blank for whatever you're minning and maxing. In other words, it's going to look just like this. It's all going to be set up just like this. It helps me to use colors. That is not a requirement at all. Oh, I didn't fill in the labels for you here. Let's see, I need to do that. Let's see, what have I got? Oh, I started filling that in already. Sorry about that.
Mrs. Ford,
Yep,
on the test, will the labels be there?
yep, I'm going to fill them in.
Okay.
Now, when you get to college and you take a real math class, they're not going to do that. They're not going to give you any of this. They're going to give you the problem, and you're going to have to construct it on your own. Just be aware. This is sort of a pretend math class here. All right. So now that I got it all filled up, what are you putting in here? Where's the 70 go?
The total acres?
Yep, that's it. That's the total acres. Where's the 20 go?
Under the P for seed cost?
Yeah, it's the potato seed cost. this is like a matrix. You got rows and columns that represent things. All right, and then where does the 60 go?
The cost per acre.
Mm-hmm. And then where does the 3,000 go?
The total seed cost.
Yep. And I'm really trying to figure out how many acres of potatoes and how many acres of corn to plant. So would you agree that, I don't know either one of those, so I'll call the number of potato acres X and the number of corn acres Y? And
But
then,
isn't it? I have a question.
Uh-huh.
Doesn't it say like $20 per acre? So wouldn't it be like 1 acre for each of those?
so in terms of the chart, do you want me to put what where? What are you asking?
I was just confused because it says like the seed for potatoes cost $20 per acre. So
Uh-huh.
then I thought 1 acre and would be in the same column as the 20.
No, because I can plant up to 70 acres. I'm not gonna put 1 and 1. I might do that, but I'm probably not gonna make much money if I do that. I wanna know how many acres of potatoes I'm going to plant. But every acre is going to give me gonna cost me $20. So if I plant 3 acres, it's gonna cost me $60.
Okay.
If I plant 5 acres, it's gonna cost me $100. I don't know how many acres I'm planting, but I know that I only have 70 acres total. So X plus Y have to add up to be less than or equal to 70. Would you agree with that? And I also know that the amount of money I spend on seed, which as you just pointed out is 20 for every X plus 60 for every Y, has to be less than or equal to 3,000? Now, this bottom row is not a complete, that's not an X, that's like, I don't know what that is. This is not a complete equation. I don't have all the numbers like I do in these other two. This is what I'm trying to maximize. Wouldn't you agree that if I'm the farmer, I want to make as much money as I can? In every one of these problems, you are either going to be maximizing or minimizing. Every time. Maximizing profit, minimizing cost, every single time. And then we got a couple more gimmies here in our constraint column. What do we know is the absolute fact about whatever X and Y are? What do we know about them?
They're greater than 0.
Exactly.
Or greater than.
Yes. And that is actually redundant to write down because I actually have that graph shown, but I want you to go ahead and write it down anyway, so that even if you get confused, you'll have something to write down. Now, I'm going to graph these two right here. I'm going to do this one in red first. I'll start with him. Looking at the size of these numbers, I'm thinking I probably should use tens as my scale. Does that make sense to you? So I'm going to do it with intercepts as always. So I'm going to cover up X. Y is 70. I'm going to cover up Y, and X is 70. And I'm going to connect those with a nice straight line. And where will that be shaded? You will be shading on your picture. I'm trying to save my board, so I'm not. Where will you be shading?
Down.
Yep, right there. That triangle right there. All right, now I'm going to use my purple marker. And I'm going to do this one. I'm gonna do the same thing. So if I cover up X, it looks like Y is 50? Keep an eye on my math, make sure it's right. And if I cover up Y, it looks like X is 150. So 70. Did I do okay with those intercepts, guys?
Yeah.
Okay. Now, I'm shading down on the purple also. So does it make sense to you that the overlapping area is a little quadrilateral right here? That's shaded below purple and below red. So we have, this is called our feasible region. Any answer in here will work in the problem, but one of the vertices will be the best answer, and that's the one we're looking for. So we've got 0, 50 as an option, 0, 0 as an option, 70, 0 as an option, and then this guy as an option. Who remembers how to find that point? Please do not rely solely on your graph. I'm going to be looking for a little algebra here.
Can you set up a system of equations between the two?
Exactly. So our red one is x plus y equals 70, and our purple one is 20x plus 60y equals 3,000. And then somehow you're going to solve that system of equations. So your options, you got so many options. You can substitute, eliminate, Kramer's rule, inverse method. There's just any of those. So I'm an eliminator, so I'm gonna eliminate. But you do whatever you want, whatever's comfortable to you. We're solving this system. And no matter what, we're all gonna get exactly the same answer. I eliminated my x's, so I got y is 40, which might be wrong, I don't know, check me. And then that means x is 30 when I plug back in. So I'll wait for confirmation from somebody before I move on.
That's what I got.
Okay, great. We'll take it then, 30, 40. Now, remember that one of those represents the maximum profit. And profit is calculated by taking 150 times your x and 50 times your y, right? That's what this says. That's what your chart told you. So we're just going to take out our trusty calculator and start doing some arithmetic. So 150... Oh, wait, that's 0, okay. So 50 times 50 is 2,500. That's 0. 150 times 70 is 10500. And 150 times 30 plus 50 times 40 is 6,500. Is everyone still with me? Okay, so you know what that means. I want a maximum profit, so that's going to come right here, right? So we're going to tell the farmer that he should plant all 70 acres in potatoes. and his profit will be $10,500. So we write a concluding statement that kind of summarizes and answers the question. Okay. Everybody good with that? All right, now what I'd like you to do is get out your, at the time I handed out notes or something, I gave you a practice packet. It's got several pages to it, and the pages are actually numbered nicely. It's got 6 pages, it looks like, but one of the pages says 9 on it for some reason. Anyway, here it is, the practice packet. And I'd like you to take just a minute or so and kind of leaf through that, both sides of each page. Well, some of them are just answers, I guess, but most of them are new problems. So flip through and tell me what strikes you as something we need to start reviewing to be ready for a test next week. We'll review next time after we take our quiz, but then the next time after that's your test, so we really have to use our time wisely. Does anything stand out as you're going through?
Yeah, can we go on page number 3 to do like the intercepts and asymptotes?
Yep, page number 3. Remember when we say the word asymptote, the P is silent? All right, does it matter which one we do? Why don't we do the top one? It looks more interesting. Is that all right, Jacob, if we do the top one?
Yes, fine.
All right. So the first thing I do, of course, is factor, right? I'm going to factor. I need to factor because that is how I'm going to find any holes that I might have or any asymptotes that I might have. Okay, so factoring is necessary. On the top, I'll take out a 2. And then I can factor what's left. I took a 2 out. That's my GCF. Always take out a GCF. And then I think I've got x minus 2x plus 1. Take a look at that and see what you think. And then my bottom factors pretty easily too. Oops. Oh, Declan's here. How nice. Declan, my friend.
Yeah.
You are quite late.
I thought we did first launch on online days.
I'm just going to chuckle at that because we have never done first lunch.
I gotta run. My bad.
Yep, definitely. All right, here we go. So, Jacob, do you notice that something cancels? So I'm going to rewrite my problem, what's left, and this is now what I'm going to graph. This is now what I'm going to graph. But I recognize I'm going to have a hole, and that hole is going to happen where x is -1. Because your hole always comes from what you canceled out. Now, to get my y, I will plug that in right here. So I'm going to have 2 times -3 over 4. So that's -6/4, -3/2. So I'm going to go ahead before I forget And I'm gonna go ahead and put my hole at -1, -3/2. All right, now I can start doing everything else. So, do I have any asymptotes in this problem?
Yeah, with the top, you can take out 2 with x minus 2.
Okay, wait a second. I'm not sure what you're talking about here. To find my vertical asymptote, it's where the denominator is 0. So my vertical asymptote is going to be over here at -5. And then my horizontal asymptote comes
Yeah,
from
that
right
was my
here.
bad. I was looking at the wrong thing.
Okay,
Yeah.
so that's my horizontal asymptote. It's going to be where y is -2. Positive 2. I don't know why I said negative. Positive 2. Y equals 2. You can tell that from the original also. Y equals 2. I now need my intercepts. And remember, your intercepts are just points. So if you let x be 0, put a 0 in, it looks like we're going to get 2 times -2 over 5, -4/5. And then if I let y be 0, that means putting a 0 in there. So we have 0 equals 2x minus 2 over x plus 5. But you're going to multiply that over. Think of this as 0 over 1 and cross multiply. So we have this. So when we solve that, we end up with 2. So our x-intercept is 2. Now, somehow, based on that, we hope we can get a picture. I'm going to erase my problem now so I can increase the size of my graph a little bit. Is there enough there for you to see what's going on? And then we've got the mirror up here. Okay, Jacob?
Yeah, thank you.
All right, who else found something? Did anybody else find something?
I just want to do a quick one. It's just on the very first page. It says find A21.
A sub 2-1 means look at matrix A and find the entry in the second row, first column. So in matrix A, what is the entry in the second row, first column?
Is it 4?
Okay, find the second row, rows go sideways, and then the first column.
-1.
Here's the second row, here's the first column. What number is in the second row, first column?
3.
There we go. There we go.
I also have a question.
Okay?
So for number 2 on the first page, is that not doable because they are the same, C and B are the same dimensions?
Yep. In order to add or subtract, the matrices have to be exactly the same size. They can be any size, but they have to be the same. So yes, problem 2 would have no answer. And that happens a lot in matrix land because the rules are so specific. There are a lot of things that get no answers. All right, anybody find anything else?
Can we do on the back of page 1, number 2?
Kramer's rule?
Yeah.
right, does anybody remember how to do Kramer's rule? It's got several steps to it. Anybody remember the first step?
Do you put them into a matrix first?
You put the coefficients into a determinant. That's exactly right. So just the coefficients are going in here. So 1, 2 for the x's, and negative 3, 1 for the y's. So 1, 2, negative 3, 1. And we evaluate that determinant. So the downs are 1, the ups are negative 6. I subtract those, so the answer is 7. So 1 minus negative 6. All right, that is indeed step 1. All right, does anybody remember what we need to do next?
Do you inverse it?
I'm not sure what you mean by that. Using that exact word, no. But here's what we do. This 7, our answer, this is a system of equations, just like we had in that problem a little bit ago. This determinant tells me that my answer is going to be 2 fractions, and they're both going to have 7 as the denominator. When you find the determinant of the coefficients, it is the denominator of the answers. Now you have to find the numerators. So to find the numerators, you set up 2 other determinants, 2 more determinants to do the numerators for x and y. But those determinants are going to look a little bit different. We cut these numbers out, the constants. And if we're finding the x numerator, we paste those on top of the x's. So we just cut that out and paste it here. So we have negative 7, 7, negative 3, 1. Notice I'm not switching anything around at all. I'm just cutting this out, pasting it here. And then to do y, I do the same thing. I cut it out, only I paste it on the y's. So that looks like 1, 2, negative 7, 7. Nothing's moving around. You're simply cutting out and pasting on top of the letter that you are trying to solve for. And then you evaluate these determinants. So I've got negative 7 on the downs. I got negative 21 on the ups. I subtract and get 14. And then I've got 7 on the downs and negative 14. So when I subtract, I get 21. Then I reduce. So the answer to the problem, amazingly, is 2, 3.
For the top, would that be a negative 28 for x?
It was negative 7 minus negative 21. So that turns into a plus.
Oh, okay.
I got a question for 4C on the same page.
What's your question?
Oh no, I just was wondering if we could try it out.
Can't do it. We can't do it. It's not possible. In order to find a determinant, the matrix must be square. Is that a square matrix?
No.
No. What makes a matrix square? What do we mean by
There
square?
has to be a dimension. It's like 2 by 2.
Exactly. Exactly. So if it doesn't have the same number of rows as columns, you are not going to be able to find its determinant. So that would be another impossible problem. All right. Anybody else? We don't have to be on just the first page. There's lots of pages here. There's a lot of stuff repeated too on the pages, but anybody see anything else that you're not sure about or want to practice while we have time?
Can we do on page 2 just either A or B?
Sure. They look like they're exactly the same kind of problem, so I'll just do A. So we want to find the partial fractions for this. So who remembers the first thing we do?
You factor the bottom.
Exactly. So that's my problem now. I have to factor the bottom, and then each factor on the bottom gets its own fraction. So I'm going to write this as the sum of two smaller fractions. One has a denominator of x minus 2, one has a denominator of x minus 1. Okay, and then I don't know what the numerators are, so I'll call them A and B. I wouldn't call them X and Y because the problem already has X's in it, but you could call it P and Q or some other letters. I always use A and B. All right, who remembers the next step?
You gotta cancel the bottom denominator.
Right, so we're going to multiply everything by x minus 2, x minus 1. Because that will do exactly what Jacob said. Whoops, that will cancel all of the denominators. So I'll be left with 4x minus 5 equal to ax minus a plus bx minus 2b. Once you get your two little fractions written, you want to multiply through by the common denominator so that there are no fractions left. Now, 4x, ax, and bx are like terms. Would everyone agree with that? They're like terms. So 4 must equal a plus b. 4 must equal a plus b. And similarly, negative 5 must equal negative a minus 2b. So in other words, the x's on the left have to equal the x's on the right, and the plain numbers on the left have to equal the plain numbers on the right. What's that?
A system of equations.
Exactly. So again, you are left on your own. You can substitute, eliminate, Kramer's rule, whatever flips your switch. Looking at this one, it seems like it's set up perfectly for elimination. I mean, I don't have to do anything and elimination happens. So it looks like B is 1. And if B is 1, then A must be 3. And then a point I'm not sure I stressed enough when we did this was, what is our answer? This is not our answer. Our answer is the two fractions that add up to that. So our answer is going to be 3 over x minus 2 plus 1 over x minus 1. Those are your two little fractions that add up to give you the original big fraction. All right, I don't know who asked for that, but does that take care of it for you?
Yes.
All righty. Okay, we still got a little bit of time, kids. Let's use it wisely. What else do you see as you flip through these pages looking at problems? A lot of which are the
On
same.
the same page, could we find an area of A, B, C?
All right, we already did that once today.
Oh, we did? Oh, okay.
Yeah, that's on the quiz tomorrow. I mean, I'm happy to do it, but we already practiced it.
I was thinking of something.
All right, does anybody see anything else? Otherwise, I'll just go ahead and do that one since we're quizzing over it tomorrow, but is there anything else?
Page, page 1, number 3.
Where are you? The back of page 1.
Number 3, yeah.
Number 3 says find the inverse. So this is a two-step process. The first step is to find the determinant, which we've done several times today. We find determinants in all kinds of problems. Kramer's rule, the area, now the inverse, we do it exactly the same way every time. So the downs are -4, the ups are 30. When I subtract, I get -34. Is everybody clear on that? Okay, what's the second step now? It's a little more random, the second step.
So you change
Oh, yes.
the places of the -1 and the 4,
Yeah.
and then change the signs of the 6 and 5.
Yep, we make this new matrix by switching these two and changing the sign of the other two. So this would be, we call this the adjoint. This would be the new matrix. This is not the inverse. What do we have to do now to get the inverse? We have to combine these two steps.
You divide it all you divide each thing by -34.
Exactly. So once you get your new matrix made, you're going to divide each number in it by -34. And then simplify. So your final answer, you're going to reduce and cancel negatives and all that kind of stuff. So your final answer will be 2/17, 5/34, 3/17, and 1/34. Does that ring some bells?
Would it be -2/17?
Yep. Yep, because that was a positive, thank you. All right, hopefully that rings some bells. Let's do a couple more and then you can go to lunch. What else?
Can we do the back of page 2, the inverse method one?
So, okay, so here, all we did was find an inverse. If we are solving with the inverse method, you need to actually now use the inverse. So the first step's gonna be the same. First thing we're gonna do is find the inverse, just like we just did. What we need to remember is that when you're using the inverse method, well, I'll just write it all out, even though you won't necessarily have to do this every time. So the original problem is 1, 2, 3, -1, x, y, 8, 3. So that's the original problem. These are the coefficients, these are the variables, those are the constants. Now we're going to find the inverse, and we're going to multiply both sides by the inverse. So doing what we just did a couple minutes ago, we're going to find that matrix and put it here. Now the reason I said that you didn't have to write all this out every time, you can, you absolutely can. But when you find the inverse, these are going to cancel. So basically your answer is going to come from the inverse matrix times 8, 3. So this is what you really have to do. That's the actual work that has to be done. So I need to find my inverse, doing what I just did. So here's the coefficient matrix. That's what I'm finding the inverse of. So the determinant will be, oh gosh, is it -7?
Yeah.
Okay. And then my adjoint, my new matrix, I'm going to switch these two numbers. I'm not just changing their signs, but that's what it looks like. I'm actually switching them, and then -3, -2. Now I'm going to divide all those by -7, and that is my inverse matrix. So that'll be 1/7, 2/7, 3/7, and -1/7. Did I get that right?
Yeah.
Now, to get my answer, I am simply going to multiply these two together. So first of all, let's make sure we can. What are the dimensions of the inverse?
The 2 by 2 and then 2 by 1.
2 by 1, yeah. So it is multipliable, and my answer will be another 2 by 1, which makes perfectly good sense, because it's going to give me x and y. So to get that number right there, I'm going to multiply my first row times my first column. So I'm going to take 1/7 and 2/7 and multiply them by 8 and 3. So I have 8/7 plus 6/7, which is 2. And then to get this number, I'll take my second row times my first column. So that's 3/7 and negative 1/7 times 8 and 3. So that's 24/7 minus 3/7, which is 21/7 or 3. So the answer to that problem is 2, 3. That system of equations could have been solved using Kramer's rule, substitution, elimination, any of those things. This is how you do it with the inverse method. We took the inverse times the constants from the original equation. And that's all there is to it. All right, one more problem. Not too big a one. A lot of these are exactly the same. They're just on different pages. On page 7, you can cross out number 1 because we didn't do Gaussian elimination, we did Gauss-Jordan reduction. So you can keep that system if you want, but just cross out those directions. Let's do one more here. I'll just pick one. Something we haven't really done today is on page 5, number 4. I don't think we've done a 3 by 3 determinant, so we'll review that real quick. Then we'll have that box checked off. So number 4 on page 5. All right, who remembers how to do this? Who remembers how to do a 3 by 3 determinant? We've done a lot of 2 by 2s. Who remembers how to do a 3 by 3?
Yeah, take 1, 3, 2, and 2, 4, 1 outside of it.
So these 2 columns right here, look at where I'm pointing. These 2 columns, I'm going to pick them up and slap them down right here. I'm not changing any order. I'm not changing any numbers. I'm not moving anything around. I am simply photocopying these and placing them here. Now, just like with your 2 by 2s, multiply down, multiply down, multiply down. So I start by multiplying down, but in a 2 by 2, I only do it once. With a 3 by 3, I have to do it 3 times, and then I total those up. So I got 4 and 0 and -3. And I'll say it one more time. You always start down and you always start there. Then we go backwards. So here we go. Up. I got -8, 0, and 6. And I'm going to total those up. So -8, 0, 6. That gives me a -2. And then I subtract, always subtract, down minus up. So the answer to that is 3. Remember, the answer to a determinant is always just a number. Okay? All right, here's what I need for you to do for me for tomorrow, okay? We'll start with our little quiz, which has 2 problems. Make sure you have a calculator because you're going to use it. But after that, the review is yours, okay? So I've given you all these problems. So please take a few moments before class tomorrow and circle ones you want to do. All right? So that when you come into class, we're not just staring at each other. All right? So circle the ones you want to review. Take a look back through all of it. Take a look back through your notes and see which ones you have a problem with. Everybody clear? Okie dokie, Smokies. I will see you tomorrow. Have a great day.
Thank you.
Thank you.
Thank you.